Hello, welcome to the video. This is going to show you how to set up your Elastic Potential Energy Lab and how to collect the data and put it into your data table. So while you're watching this video, feel free to pause and rewind so that you can get caught up on your own lab. And if you have any questions, if there's anything about this that's confusing or you're not quite sure, please ask me, email me, or whoever your teacher is, and they will gladly help you out. All right, so after you click on the link to the simulation on your lab report, the first thing you're going to do is click on the lab option right here. So once you click on the lab option, then you're going to do a number of things. Let me see if I can do that. There we go. So this is what we're going to be using to collect our data since we are all doing distance learning and we can't do this in person. So the first step is to come up to your spring constant 1 right here. Take this little icon and you need to slide it all the way over to small. Okay. Next, you will click the displacement. You will click the movable line. And then for gravity, come click this right arrow over till you get 10. So that's what we're using for 10 in our gravity in this class, 10.0. And then the last thing you're going to want to do is this damping option, slide it all the way to none. All right, so that box is finished. So you should have displacement, movable line, gravity's at 10, damping at none. And then the next thing is this little ruler icon that you see here. Click and hold and drag so that the ruler, the bottom of the ruler, is on this blue line down here where it says height is equal to 0. Which means that if the height down here is 0, then the height at the top of the ruler would be 100 centimeters, or it would be 1 meter. This is 1 meter tall. Okay, let me just show that for you. This is 1 meter tall. From here to the bottom of that blue line, to that blue line right there, 1 meter. All right. So now your simulation is actually almost set up, sorry. You want to also hit the pause button and then click slow motion. And once you have all that, now your simulation is ready to go. It's all set up. So the next thing you need is to have your data table open because we're ready to start collecting data. So go back to your lab report. And this section right here where it says click on this Google Sheets data section. If you click on that link, you are going to get a data table that looks like this. All right, but if you try to click into it, you won't be able to change anything. So you're gonna have to make a copy. So if you come up to File and make a copy, then it'll save into your Google folder, and then you will be able to edit that one. So you have to make a copy of it first. So after I make a copy, this is what it should look like. Okay. So we have a lot going on here, and we have our diagram off to the left to help remind us how we're going to get our energies in this situation. All right. Here are our masses that we're hanging on to the spring: 50, 65, 75, 85, and 100. And we're going to be measuring a lot of stuff. We're going to measure the distance the spring stretches, both in centimeters and in meters. And as you discussed at the beginning of your class, the reason why we need it to be in meters is because joule is made up of a hodgepodge of different units. It's kilograms and meters. So that's why we have to change from centimeters to meters to match that. And that's why we have to change from grams to kilograms to match that. All right. So first thing you should do is collect your distance stretch data. So let me just do the first one with you. I'm going to do this first entire row with you so you know how to do it. So we are going to set our mass to 50 grams. So back on the simulation, see this mass up here? Right now it's at 100 grams. I'm going to just slide this over to 50. And if you slide this back and forth, you're going to see how the orange one changes. So I'm going to select 50. I'm going to then click, and I'm going to attach it to the spring, which it does automatically. And then I'm going to bring the spring up until the top of the mass matches the top of the ruler. Okay. So one of our things in the data table is our starting height off the ground. Well, our top of the mass is at the top of the ruler, and here is 0 meters, so the top of the mass is 1 meter above the ground. So our starting height is 1 meter. Okay. Next. Here's kind of the tricky part. So what you're going to want to do is we're trying to figure out how much elastic potential energy this spring has. And so like our diagram shows, we're going to let the mass go and it's going to stretch the spring, and we're going to try and stop it right when it hits the bottom of the stretch, right before it shoots back up. Okay? So let's give it a try. That's why I like slow motion, because it's easier to tell when it's about to stop and shoot back up. Okay, so I'm gonna hit play. And right about there, I hit pause again. That's when it was about to stop and come back up. So this is how far I want it to go. And so what I'm gonna do, you see this little red line? If you want to use it, you can help you see where on the ruler the top of the mass is. And I can see that it started from here and it stretched 43 centimeters. All right. So I know that my spring stretched 43 centimeters. So I'm going to place 43 into the distance stretched. Okay. So now let's do this entire row together. I have the distance stretch, I have the mass, I have my starting height of 1 meter. Let's do some conversions, okay? So you should have a metric conversion table in your Google Classroom under the helpful class resources. So use that table to help you convert these units. Remember, for this one, we're going from centimeters to meters. And so that would be 0.43 meters. So 43 centimeters is the same as writing 0.43 meters. Okay. Let's convert the mass now. The mass is in grams, and I need to go to kilograms. And to do that, I need to divide by 1,000, and I would get 0.05 kilograms okay? So now that I have my mass converted to kilograms and my distance converted to meters, which we need because, again, a joule is made up of meters and kilograms, and we have to have our units match. Let's talk about the ending height now. So the mass started at 1 meter above the ground. And as you can see, it stretched 43 centimeters. So how high off the ground now is the mass? Well, to do that, you're going to take your 1 meter and minus your distance that you stretched to get your height above the ground. And the 1 you're going to minus, so you're going to take 1 and you have to minus meters from meters. Okay, don't minus meters from centimeters. That's not going to work. So meters from meters. 1 minus 0.3 is going to give you 0.5 6, right? Am I wrong? Sometimes I gotta check my own work. I am wrong. 5.7. 0.57. Excellent. So I have a starting height, I have a mass, and I know gravity. So I can find out the starting gravitational potential energy above the ground now. And I like to do this using a calculation instead of just trying to do it on a calculator. So if I did this ending height instead, I could have done the same thing. I can set this equal to what's in this box. So my 1 minus my distance stretched. And there you go, I get 0.57 again. Now let's do this one. To find my starting gravitational potential energy, well, gravitational potential energy is mass times gravity times height off the ground. The starting height off the ground. We said the starting height off the ground was 1 meter. So again, I'm going to set this equal to my mass times my gravity of 10 times my starting height off the ground, which was 1 meter. And I should get 0.5 joules. I'm going to do the same thing for my ending gravitational energy. Okay, only this time my mass is still the same, gravity is still the same, but my height above the ground is different. So now this is my ending height. I want to use my ending height. So my mass times gravity of 10 times my ending height this time. And I get 0.285. Okay. Now, remember our law of conservation of energy. When we start, the mass at the top, the starting gravitational energy is the same as the total. Okay, and our ending gravitational potential energy is here. So to find my elastic, I just have to take my total energy and I minus my ending energy. So in other words, my elastic energy is equal to my starting gravitational energy minus my ending. And if you hit enter, that is the number you get for your elastic energy. And now you have everything filled in, okay? And now the next step is to move on to a mass of 65. So you're gonna slide this until the number in the box says 65. Start it from the top and do that whole thing all over again until you get all of your data filled in. And then the very last thing you're going to do is when you are finished collecting data, start at box or cell B1 and click and hold and highlight everything, your whole data table, and click copy. Control C or Command C if you're on a Mac. Copy and then come back to your lab report and click right underneath and paste. And it's going to give you this option right here where it says link to spreadsheet. Definitely link it to the spreadsheet. And there we go. Your data table is now in, once it's finished, it will be in your lab report. All right, and that ends this, this tutorial on how to collect your data for the Elastic Energy Lab. If you have questions, please ask me or your teacher. They will be happy to help you. All right, and good luck collecting data.